Hey guys and gals, hello, welcome. How you doing? How are you doing? Like seriously, I mean that. How are you doing? So great to have you here. Thank you for hitting that play button. Let's go! I know I say that a lot, but that's to pump you guys and gals up. Get you excited for some mathematics. Oh, yeah! Yeah! That's why I'm doing mathematics, because I'm a terrible singer, guys. Drum roll. I actually have that, to be honest. Let's see if I can quickly find it. Oh, of course, why not? Drop in the commercial. I gotta see a commercial before I play the video first. Ah! God, it drives me nuts. Yeah! YouTube, start sharing the videos. Sheesh! I don't want to get on a tangent. My hard work, my Unity project, days and days and weeks working on a project, getting sound files from a particular website. I even mention where I got the music from in the credits and everything. But, I don't want to get on it. Music trolls, that's all I can say. They drive me crazy. Okay, guys. All right. Positive vibes. I don't want to get on that. I don't even know why I was thinking about it. I'm sorry, I apologize. You guys. Yeah. It's just, when you work hard on something and then somebody wants to steal credit for your hard work. Yeah. Okay. Yeah. Okay. All right, let's go. I want to check the stream quickly. Good vibes, positive vibes. Only if I had 2 minutes in a boxing ring. That's all I would need. Just a little bit of warm up, a little bit of practicing. Okay, checking the stream quickly. All right, good, perfect. I hear my voice molecules. That is a plus. That is a plus. Okay, so let's go. I'm gonna quickly throw this out. This is for you, parents, you awesome parents, making the decision to homeschool your children, your children's, your kids. I support you in that decision, and I fully understand. I totally get it. I am with you, here to help. I am assuming that you have a lot on your plate. I imagine you probably do. So here to help you with the old mathematics. Mathematics! Oh, yeah! Okay, that's my singing. You can't copyright that! Kind of in a good mood today. Kind of. This is good, though. This is good. We are going to get to work. We're going to get some mathematics. Also, you students, it's great to have you here as well. If you're searching the old YouTube web looking for additional mathematics support because, well, you probably might have a terrible teacher. It's possible. It's possible. That is the thing. So whatever reason, it's great to have you. Great to have you. Hopefully I could help you. I could do anything from grade 9 to grade 12 mathematics. Okay? If there's a particular area of mathematics that you want me to kind of focus on and do a special series for you guys, I'm down. I'm totally down to do that. Okay? Kind of taking a break from the Unity stuff. Again, if I do create something, some other music trolls that just want to ruin your life and take credit for all your hard work, and then and then you get copyrighted, and then you can't even make any money off the video because some other troll decided, well, hey, even though the music's not really theirs, but they decided to claim it. Yeah. Okay, guys, I'm sorry. I'm just letting you know what's up. It wasn't a good feeling. It honestly wasn't. It's not. It's like doing all your math homework, and then someone takes your math homework and they hand it in and they put their name on it and say it's their math homework, right? Is that right or is that wrong, right? It's wrong. Okay, I don't care what any other person says. It's wrong. Okay? All right. Quick coffee, and then we're going to get to work. We are going to get some works done. The great thing about YouTube, guys, if you're watching in that, and I kind of go on these little side tracks or whatever, I am going to teach mathematics. I'm not going to get off topic too bad, right? I will keep myself in check as well. But you can skip forward, right, to the parts for learning. So it's great to have you. Of course, when it's live, that's obviously harder to do. Well, impossible. But either way, great to have you here. You're awesome, awesome. Turn it up. Oh, yeah. Okay, what are we doing today? So we worked on some few problems. Should we recap? What should we do? Or we should just get right to it? I guess you can kind of go over this. This is from last video. We worked on this. Again, I'll just quickly explain. I guess we could talk about complementary angles quickly. Complementary angles, usually it's two angles. They'll add up to sum of 90 degrees. Supplementary angles can either be two angles or three angles. 2 and 3 seem to be the common, and those angles add up to a sum of 180 degrees. So to even add, to let you guys and gals know, even with this triangle here, right? So flip that switch in the brain. We're getting to it, guys. Okay, let's get some work done. All right, appreciate you being here. Much love. You're awesome for learning. Okay, 120 IQ and above club. That's what you guys are part of here. Okay. All right, we're gonna get you there. Okay, so this is actually supplementary angles as well. So there's actually 3 interior angles, and they all add up to 180. So the supplementary angle concept actually applies the same, and yeah, 4 triangles as well. Turn that up, isn't that awesome? So we have here with a right triangle, we have a complementary, this would be a complementary angle because this symbol here means 90 degrees, okay? Without it, I mean, all you could do is assume that it's not a 90 degree angle. So, but with 90 degree corners or perpendicular lines, you really want to represent a 90 degree angle with that symbol. It's just a little box symbol, okay? So this would be a complementary angle, 2 angles. So we have 2 angles, one interior angle and another interior angle that add up to, together they will add up to 90 degrees. So it's really simple math, guys and gals, right? Don't let it scare you. Don't let it overcomplicate you. It's just a line that's intersecting, a 90 degree, which is creating 2 angles. It's not really, that big of a deal. It's just a line, right? And it creates a couple of angles. So to find this angle, x is basically going to equal 90 subtract 65. Okay, that easy. I'm going to be here. Okay, so this is why we talk about straight lines, straight angle. What's a straight angle? Well, a straight angle could be either x, horizontal, or vertical. It's all the same. Basically, a straight line, it's a line segment. It's not a ray because it's going in both directions. So a line segment, and it's obviously still a straight angle, right? So that's 180 degrees, right, guys? Even though it's pointing in a different direction, it doesn't matter. You can orientate it however you want it, and still, regardless, it's still a straight line, a straight angle that is 180 degrees, right? So we have here the same thing, same concept applies. We have this straight angle. Okay, even though like it's just to us in our brain, it's just a straight line, but you know, it's a straight angle too. Crazy, huh? So, to find x, it's the same thing, same principle, except we're using 180 degrees this time. So that would make it a supplementary angle, right? Remember, complementary 90, supplementary 180. Okay, so 180 take away 38 gives us x. Okay. Here, problem C. So we have a straight angle, plus we have a perpendicular line. I guess that would be a ray. This would be, I guess you could call a ray, but this would be a bisecting line, right? So going over the definition, what is a bisector in math? I guess that'll work, or in geometry. It doesn't really matter. In geometry, a bisector is a line, ray, or plane that divides a line segment, angle, or other geometric figure into two equal or congruent parts. Equal, right? So to verify that and confirm that in your mind, you can see we have x here and x here. Well, x is going to equal x, right? It's going to have the same numerical value no matter what, right? It's not, if it was x and y, that would be two different numerical values, but we have two x's, therefore equals, they're both exactly the same in value, right? Makes sense? So just breaking it down here, we have a 90-degree angle, which is bisected. So essentially you're going to be just going 90 degrees divided by 2, which gives us 45. So we only have two angles, right? So x therefore is going to equal 45 degrees. And then for here, lastly, we'll go over D quickly. Again, the same rule applies. A plus B plus C equals 180. You could call these any variable name you want. It doesn't have to be A, B, and C, guys. Whatever you choose is up to you. You can call it X, Y, and Z. You can call it LMN. Okay? They're just variable names, and you can kind of create them and choose what variables you want to use. Okay? Again, 3 interior angles equal 180 degrees. So we're given 2, so you just take the 180 and you're subtracting, right? Because we have to find the missing number. That's why we're subtracting. 180 take away 85, take away 35 gives us x. Okay, and then you can write down x. That's easy. So now here we have, again, a straight line, right? Or a straight angle. Same concept, except this time it's a horizontal one, but you know, by all means, we still have a straight line, right? Which adds up to 180 degrees. We have two angles. This is still an angle. Reflex, not a reflex. This one is a obtuse angle, right? Right here.
You didn't stand a chance.
Oh, okay. All right. Can't win the lottery, can't be lucky. Yeah, can't win on anything apparently, it seems. Okay, anyways, carry on. So we have a obtuse angle, and x and y together will equal 180 degrees. Okay, so now we know x, right? We figured it out based on the triangle. So all we have to do is take 180, subtract x, because now we know the value will equal y. So y is going to equal 180 subtract x, and that'll give you y. Okay, give me a sec here, guys. Just one sec. Bear with me, and we're gonna get back to work here. I just gotta mute a sec. All right, I'm back. Appreciate your patience. You're awesome, awesome. Okay, let's continue. So we'll go over the concepts here, some more concepts. I know we kind of been over it with the definitions and such. Hopefully you've watched that. Understanding, you kind of have to have these memorized in your mind so you can work with these parallel lines and transverse or something like that. What's that called again? Traverse, I think it was, something like that. Transversal line. Okay, so we'll be coming up with seeing problems, where we have two parallel lines and then you'll have a transversal line that's kind of intersecting through both the lines. So stay tuned. Oh, there's an example right there. We have an example right here. Two parallel lines. This is the transversal. Okay. Oh, it's right there. I guess if I just read a little bit. That's okay, guys. All right. Okay, good. Congruent angles. Let's start with congruent. Okay, we'll go over it quickly. I know you guys can read it, but congruent angles are the same. Okay, so congruent means same. So this shape here could actually be larger, but it doesn't matter if it's scaled or zoomed or scaled or whatever compared to the original. It's still going to have the same angle. As long as this line doesn't change, rotation, the angles are still going to be the same. Okay, and then you have opposite angles, right? It's opposite. C is opposite D. A is opposite B. Okay, so another thing, right? Set it in your mind. A is also going to be equal to B. Okay, they're exactly the same angles. And in turn, C is also going to be equal to D. Okay, and we have two line segments that are basically intersecting or crossing each other, which creates a form of angles. All you really need to remember is if you're given this, then you'll know that this is the same. If you're given this, D, then you'll know C is the same. Okay? Perpendicular lines. You'll know lines are perpendicular if you see that little box shape, which is the symbol for a 90-degree angle. Okay? This you guys could read if you like, right? Just pause if you want to read it. Parallel lines. So parallel lines, basically they run parallel with each other. It's like two vehicles driving down the roadway in the same direction, right? Without crossing the line, sort of thing. Then, of course, we got this rando that doesn't know what a stop sign is, right? He's, his elevator isn't going all the way upstairs for some reason. So, just making jokes. But so we got two parallel lines, and then we got this transversal line, which is intersecting right through it. Again, it creates angles. So you'll have the same kind of concept. I wish I could zoom this a little bit bigger. Let me go. What is a transversal? We'll get a larger image for you guys and gals, okay? Something a little bit larger. Okay, let's see if we can find something. Let's see. Okay, well this would kind of work. I'm just gonna snipping tool it quickly. I like to give you guys and gals some visuals without me saving all this stuff on my computer. I'll just kind of do a quick snipping tool, share it with you. So we have two parallel lines, right, and the transversal line. Okay, so I can't really zoom it any bigger, but it's a little bit better. So you can see B. So if we actually talk about this, there is some other terminology which we talked about. Corresponding angles, alternate interior angles, same side interior angles. I guess we could talk about that quickly, which we should. I got a bunch of little images here saved for you guys and gals. I just gotta, where did I put it? What's this again? Oh, here we go. This will work. Kind of. Well, no, I don't really like it. The guy's got too much information going on in there. Is this it? Yeah. Okay, here we go. Alternate angles. Let's talk about it. Alternate angles are angles that occur on opposite sides of the transversal line. Okay, so they're opposite. You can see the angles are not wide angles, they're narrow angles, like an acute angle, right? That's why they, that's why this is taught, guys, right? The acute, right? Obtuse, right? That's a wider angle. This is a narrower angle, right? That's why that information's shared and taught to you guys, right? Or us. I had to learn this stuff too, right? So, we have alternate angles. They're alternate each other, and they're also the same angle, right? Because they're narrow. If you can see, I don't know, I see other people teach this shape, like the letter, like I think that's kind of lame, but you really don't need to all that extra information. Excuse me. You can clearly see that this angle is a narrower angle compared to this angle. This is a wide angle. This is like an obtuse. This is an acute angle. Same thing with here. So you can clearly see they're both going to be the same angle. Like, because the line is a perfectly straight line, right? And it's intersecting across both parallel lines. Well, it doesn't matter. As long as it stays at that angle, all angles are going to match, okay? Nothing changes. Same thing with here, B. This is an obtuse angle, right? B here, they're opposite each other. I guess, is that what they... Yeah, here's that Z shape thing. I think that's just stupid. But anyways, you don't really need to, like, who cares about that? You just really need to know that this angle is opposite this angle, or alternate angles. Okay? What else do we have? Difference between opposite angles and adjacent. So we have opposite and adjacent, right? So this is source Q math, okay? Because I am going to share the source, so you guys know. Adjacent angles, okay? Angle 1 and angle 2. Angle 1, angle 2. They're adjacent to each other. They're like adjacent, just think like next door neighbor. Like there's a fence, right? They're really literally touching each other. So they're adjacent to each other. Okay? 2 and 3 are also adjacent to each other. You can see the pattern. It's going from 1 to 2, adjacent. 2 to 3, adjacent. 3 to 4, adjacent. And 4 and 1, adjacent. And then you have opposite. 1 and 3 are opposite, right? Make sense? They're opposite. And 2 and 4 are opposite. Okay. Alternate. Hold up, guys. Just gotta deal with the commercial quickly. I don't normally get the commercials much, but I guess we are today. That's okay. I do play the same music a lot, I know, guys, but this video literally has the least amount of commercials and I don't get copyright. So it's a win-win, winner chicken dinner all day Sunday breakfast, for the channel. Okay? Because the music trolls can't troll me with this music, so which is awesome. Okay. Alternate interior angles when two parallel lines are cut by a transversal. This is the transversal. The pairs of congruent interior, congruent is same, right? They're the same. I guess I could use that terminology as well. Okay, they're alternate interior angles. Again, they're still interior. And they're also alternate angles. I know that's a lot of extra information. You just really need to be aware, that this is going to be the same as this. Really, that's kind of the main goal here. The terminology behind it, like, you can memorize it and that. It doesn't hurt. Like, obviously you can see that they're alternate each other. They're not adjacent, right? And they're congruent, meaning the same. Okay? Well, looks like I actually copied that image twice. Congruent angles. Two angles that have the same angle measurement, right? Congruent. Even though you have two different triangular shapes, there is the chance that, look, this leg here is longer than this leg. That's why this leg ends up being longer, right? That's all it is. It's a distance thing. The angle here is exactly the same. Okay, so therefore congruent. Corresponding angles. Two parallel lines are cut by a transversal. The pair of congruent angles on the same side of the transversal. So these would be adjacent, right? But the values for each angle are going to be different, but together they will add up to 180. So that means that they're supplementary angles, right, guys? The green and the yellow. Again, a straight line creates a 180-degree angle, right? Same thing with the opposite side. It doesn't matter. It's all the same. Yellow here is going to be yellow here. Yellow here is going to be yellow here. They're all going to be the same value. Green and green. They're opposite each other. Green and green. Green and green. Okay? Same concept. Okay, same side interior angles. G and H, they're both here's some good information here, right? To learn. So of course, which makes sense, kind of like we're explaining here. Like, it doesn't matter the orientation. Okay, how do I say this so it doesn't really end up being confusing? But you can see that this narrow angle and this obtuse angle together add up to 180, right? Okay, so going to here, the same concept, even though we still have a transversal line, but this angle and this angle, it doesn't matter how you look at it, they're still together going to add up to 180 degrees. Therefore equals their supplementary angles, right? Supplementary add up to 180. And it could be two or more angles. Okay, guys? So that's the concept. Okay, and it doesn't really matter if it's on this side of the transversal or if it's on this side of the transversal. It's still all the same. Okay, it doesn't even matter if the transversal is going at a different angle. The concept is the same. It does not change. Okay, that's the main goal here, right? You don't need a perfectly straight line. Like, as a matter of fact, if you really think about it, this blue angle is actually right here. It's the same angle. Okay? They're I want to use the right terminology. Well, they're going to be congruent angles, and they're also going to be alternate interior angles. Is that right? I don't know. Anyways, I want to double check to make sure. I don't want to give you the wrong information, but I do know that these match. Okay, let's go back here. Alternate, yeah, alternate, but they're the same. They're congruent and they're alternate. Congruent and alternate. I guess it would be the opposite. Opposite would be opposite. I know it can kind of mess with your brain a little bit. I know, guys. Don't let it confuse you too much. The main thing is to just take note that, just look at the angle, right? You can see this is a wide angle. You can see this is a wide angle. Therefore, they're going to be the same. You can see this is a narrow angle. You can see this is a narrow angle. Visually, right? So therefore, they're going to be the same. These will be opposite for sure. This will be opposite this. And they're also congruent. Okay? And it doesn't matter if the angle's here or here. They're going to be at the exact same angle, so they're congruent. That's kind of the main what I want to say here. I don't really care if they're alternating or opposite. I don't care about that. We do care, but the main point of understanding here is to see that this is an obtuse angle, this is an obtuse angle, therefore equals they're going to be congruent. Okay? I'm going to leave it at that. We can close that as well. So we talked a lot about this. Hopefully that helps. Hopefully I didn't do any protractor stuff for you guys and gals. It's obviously hard for me to kind of display how to use a protractor. I don't know, do some of you need me to do a special video on how to use a protractor? I'll try to figure a way of doing it, but I'm not sure how. I could bring up what is a protractor? I know it seems silly to even ask that kind of question. Most of us know what it is. You get it out of your compass set. Tractor. Right, and there's different styles of protractors. Some are gonna have like no center. They'll have a hole right through them or something. There we go. I'll just snip this. This will work. Source. I'm not keeping the image. I'm just sharing the image. Okay, from Brighterly. Okay, what is a protractor, right? Protractor is a tool in geometry, usually made of plastic, glass, wood, or steel, used to measure and draw angles. You could get metal ones, which are nice. You could use if you want to measure angles, like physically measure angles in real life. I used to do that when I was design and drafting. Have like your metal protractors, I guess. They're kind of two metal strips that you could actually rotate, so which is kind of cool. And then calipers and a measuring tape. I used to design oil and gas equipment, so, but not to get into that, but blue collar and educated, field experience trumps bookworm. Yeah, I'm a bookworm, but I could use my hands. So that's the difference between myself and a bookworm. I'm not scared to get dirty. I'm smart and I can get dirty. That's the difference with me. So anyways, not to go on a tangent, but my main point is it doesn't hurt to get that real life field experience, guys. Okay, I used to work for a major oil field company that does drilling. So anyways, okay, so I got getting back on track here. Okay, that's talking about math and real life experience and schooling. Okay, so I've actually got a larger, this is bigger now, so I have more room to work here, and it's not as much as a mess, not as much of a mess. So this is for you guys. I did it for you so that when I'm doing my calculations, it's not so cluttered. Okay, so right here, yeah, what I was kind of showing, you can see it goes from 0 here and all the way to 180 here, but you can also have 0 here and go 180 here. Now, it just depends on, I think this is my thinking. Okay, so this is normal for me. So I guess it depends on what angle you want to measure. If you're going to measure this angle, I guess you would use this side, right? Just, this is the center, right? Think of it as the center of the circle. And where's that image I was looking at? Right here. Silly me. So I would just put the intersection like right here, for example. It depends which side you put the protractor on, right? You would put the center of the protractor right there, or you could put it right there. It doesn't matter. Okay? Depends on what you're going for. Now, in regards to this, that's why I'm showing this counterclockwise. Like, I'll look at this image here, right? And normally I go from, this is the pivot point. So rotating, this line is rotating, going, okay? Same thing with here. So this one's less than 90, so it's an acute. This one's greater than 90, right? I always go counterclockwise with my measurements. That's just the way I do it based on this here. Okay, this concept. And I'm showing and sharing this with you guys and gals because you're going to see this as you progress and advance in mathematics. You might as well have, you don't need to fully understand all the ins and outs of it, but just seeing it visually, you're already ahead of everybody else because you've got it already in the back of your mind. Oh, hey, this is this is that. So by the time you get to this area of mathematics, you're just going to ace it. You might even get bored. Try not to get too bored, right? That's the thing, right? Once you already know something and you're like, oh my God, this is easy, and everybody else is struggling. Again, right there at that point, you just became a 120 IQ individual. Okay? You're part of the 120 IQ club at that point, as far as I'm concerned. So it depends where you're going to put this, right? So if you're going to go an acute, you would measure 0 from here and go this way, right? So this would be for counterclockwise, and this would be for clockwise. Again, in regards to this, it's counterclockwise we're working with. Okay? And again, to make a note, right? You can, here, let me just draw something. You can have a line here, right? You can have, let's just say this is center. You could have a line here, right? So you would be, let's say this is unknown, and you would be measuring this with your protractor, right? But you can also have a mirror image of that line, right? So essentially it would be a mirror image, right? So all these angles, this angle and this angle is going to be the same. This angle and this angle is going to be the same. As long as you drew them properly, right? Anyways. Okay. So that's basically it, right? And then you line up, your line will be behind wherever, and then you just kind of look wherever it matches up, the closest, right? You can count, right? Just take note if you got a line that's going this way. If it rotated from 0 this way, then you're going to be in the 130, 140, 150. If you got a line this way, maybe it rotated from here in this way, right? Just depends on the angle you're working with. Okay? All right. Quick drink of coffee. All right. How are we doing for time? We're getting up there. Hey, Mitch, very handy. The mech tent. Hey, man, you're awesome. First time checking out. Gonna need a tutorial for calipers though. I sometimes struggle with reading them. Oh, okay. Are you well, the digital ones will obviously be easy to read because they're digital. But yeah, you're talking about, I guess you would call them mechanical maybe. Yeah, I guess I could try to do a video on that just for you. I appreciate you stopping in. Shoutouts to the mech tent. Now, you're lucky. Normally I don't check chat because I sometimes get super focused, and then a lot of other times as you can hear, there's background music playing. So a lot of times, excuse me, a lot of times I'll have, because I got a dual monitor setup, I'll have the YouTube video kind of covering everything because sometimes commercials pop up and I want to quickly pause them, right? So sometimes I have YouTube videos covering my OBS studio. Appreciate you being here though. Awesome. I'm going to make sure, check it out in comments. I'm going to shout you out in comments of this video. Because I like to do that for people that, want to learn and high IQ, intelligent people. Appreciate you being here. Let's go. All right, let's continue. Where are we? We're just kind of going over basic geometry stuff. Some of this I'm kind of following a plan a little bit, but I don't know. For me, my mindset is this is kind of grade 10 stuff. Grade 9, I can't really recall. Like, do they teach this stuff in grade 9? I don't recall. But either way, I think this would help for anybody that's in grade 9 or grade 10. That's what I'm thinking. This is for you parents that are homeschooling your kids, childs, and also for any students that are looking for extracurricular support because maybe their actual math teacher sucks. Sorry, guys. Hopefully you understood what I was trying to say there. They might be trash. All right. Myself, I like to give tips and tricks and give little quick shortcuts, and just based on my experience from grinding mathematics for a number of years, and shortcuts and what else not. And also I like to explain things too, right? Maybe I might over explain. Bear in mind, guys, sometimes I just think of the person that's new, right? Like, I don't know everybody's level of experience in regards to mathematics. Some of this might be really easy for you. You might already know most of this. If you do, you can sit back, watch the video still, which would be great. Or you could just kind of jump to the next video. It's up to you. Working on a series here for you guys and gals. And again, I'm just assuming that people that are watching, they might be struggling. So I try to go a little bit above and beyond in explaining things. Thank you for understanding. You're awesome. Okay, so what do we have here? I don't know if we're gonna do any of this stuff here. Let's see. Oh, so this one here, something like this, it's no different than what you see here. Really, what you're gonna want to do is just line up your ruler with this, just slide it down, or you could actually measure the distance from here to here, but it has to be perpendicular. You could like measure the intersection point, and just imagine a right triangle here, because you could actually draw a right triangle right there, and then just measure that distance, and then you could go down here and then just measure the distance, and then just put a little dot, and then you just line up your ruler, and essentially you're just drawing to the second parallel line. That's all you're doing here. Okay, and then if you want, you could go above and beyond and take your protractor and measure the angles. You know, whatever you want. Okay, so here we got a little problem. Okay, don't let it scare you guys too much. Okay, they're just lines, roadways. Really, they're still just lines. I had to kind of stop and think about how to figure this one out, because it's like, well, solve for X, Y, and Z, and I'm like, I started thinking, I was already thinking Pythagoras theorem and all that, and I'm like, they didn't even give me a distance value. Hold up. Okay, I've already done the work a little bit. Okay, we've gone over congruent and supplementary and opposite angles and all that stuff, right? I can't really... Can I zoom this a little bit? Yeah, I can. I'm going to zoom it just a little bit. Okay, there. That's better. Okay, so we basically just have airport runways and such, you know. And we got lines essentially intersecting and crossing each other, right? So we're going to begin here. So they're saying X, right? X is actually easy. Okay, this is easy. So like we were talking about, so we have two intersecting lines here, right? Hold up. I got a commercial. See what I mean? No, I'm not trying anything what you're trying to sell for free. Get canceled. Get blocked. How about that? I like to block commercials now. It's fun for me. Okay, so we're going to focus on X first. All right, so if you look, you can see these two lines here. What we have is a narrow angle or an acute angle, and this is an opposite angle. Opposite. They're going to be exactly the same angle, guys, gals. So therefore, X is going to also be 43 degrees. I can't write it here, but X is 43 degrees. What's the reason? Well, they're congruent for one, and two, they're opposite each other. Okay, so that's the reason. That's my reason anyways. Now that should give you a check mark on your exam. Y. So what's Y here? Okay. Y. Ah, here we go. Looking at this, same concept, guys. The lines aren't changing. Everything's still the same. This isn't quite a 90 degree, but that's okay. It doesn't affect this angle here. This angle is based on these two lines here. This line and this line, they're parallel with each other. Essentially, this is the transversal line. Okay? This line is parallel with this line. Okay, so therefore, because they're parallel, and this transversal line is exactly a straight line, this angle is going to be exactly the same as this angle. So they're both interior angles. So, and as you could also see, it's an acute angle as well, right? It's an acute angle, not obtuse, right? It's a cute angle. It's handsome and beautiful. Okay, back to here. So my answer is y is also 43 degrees. The reason? Corresponding angles, and they're congruent as well. Corresponding, is that the right answer? Corresponding. Let's see. Hold up. Is it this one here? So if I'm to look at that, they're both interior, the transversal. We're getting a lot of information going on here. Alternate. I guess they're kind of alternate angles. They would be alternate, right? Guys, I really don't care about the opposite. Makes sense. Adjacent makes sense in my mind, but this other concept, to me, they're the same. My answer is because, well, one, they're both acute angles. Two, we have two parallel lines and a transversal running in the same plane, so therefore they're equal. That's my answer. Corresponding angles, I don't know, I guess that's the right answer. Okay, so let's work on Z. Okay, let's figure out Z. Z is unknown. Okay, how do we figure that out? Okay, all right, this is kind of easy. There's a couple of ways to do this. Okay, so if we look at this 85, this is obviously not a 90-degree angle. That's fine. So we have two parallel lines with another transversal line. Again, this is going to be a different transversal. These are both our main parallel lines. Okay, take note, guys. So therefore, this 85 degrees is also going to be the same as this right here. Okay, this is going to be opposite this. So 85 is going to be here. 85 is going to be here. This is unknown, right? So remember the concept of kind of what we did here. This is kind of similar, right? You have two angles and you have a 180-degree angle. We can figure out, so how to answer this. There's many ways to answer this. These are two interior angles. They're, I guess, alternate. They would be alternate. And these are our parallel lines. This is our transversal. Therefore, this angle is going to be the same as this angle. This angle here is the opposite. It's going to be 85. This is going to be 85. Now remember, two interior angles, we have a straight line here, so there's 180 degrees here, right? So we can figure out Z easily, Z, whatever, just simply by going 180 subtract 85, which gives us 95 degrees. Okay, so Z is 95, and I wrote down corresponding for an answer. I don't know why I wrote corresponding. I don't know. Also, the last thing that we could do as well, guys, just as an extra tip, you can see there's a triangle here, right? And the same concept of this here, three interior angles all add up to 180 degrees. Let me zoom that up again. We have a triangle here, right? So now we know this interior angle here is 85 degrees. We can figure out this angle. Okay, easily, because we know we were given the 43. We know this is 85. All we have to do is go 180 minus 85 minus 43 will give us this angle here. Okay, big yays on that. What do you think? Or drum roll. Let's go! I think that's going to be it for this video for now. And then next video, if you want, you can kind of stop, pause the video. Obviously, if it's not live, you could do that. I guess you can still pause when it's live. That's fine. But if you want to kind of read up on this before the next video, I'll kind of go over it a little bit, maybe quickly. The information's there for you, and then we're going to kind of continue on. Okay, I appreciate you guys being here and watching. Parents, students, those that want to be part of the 120 IQ and above club, you're all welcome here. I appreciate having you. Quick shout outs to the mech tent for dropping by and your comments in the stream. That's awesome of you. That's it. I'll see you guys in the next video. Thank you for watching. Johnny Whiskey Tango Sharp. Coding, Unity, codings, and mathematics. Got a lot of things going on here, but mathematics is something I truly enjoy and love. It's one of the things I kind of mastered, while I was studying and learning and growing. All right, guys. Whoever you are, wherever you are, have an awesome rest of your day. I will see you in the next video. Take care for now. Peace.